This is Knowing the Universe, the History and Philosophy of Astronomy. And I'm Professor Impey, Distinguished Professor in the Astronomy Department at the University of Arizona. In this module, we'll be considering the discoveries that can be made with the telescope and its invention and early use by Galileo, and what effect it had on the Copernican revolution. Galileo, a major figure in the history of astronomy, probably the first physical scientist. He was born in Pisa to a musical family and was always interested in music and art. He was a polymath. Throughout his life, a champion of Copernicus and his sun-centered model of the universe. We can really think of him as the first modern scientist. He used mathematical models, and he was dedicated to experiment as a way of learning about nature. He was also arguably the first modern astronomer, since he was the first to use the telescope for real discoveries. He forms a bridge between Copernicus and Newton, who we'll consider next. He was a younger contemporary of Tycho Brahe and an older contemporary of Johannes Kepler. His personality guaranteed that he lived a tempestuous life. He was by turns feisty, obstinate, smart, and highly driven, and as everyone knows, he got himself into big trouble later in his life with the Catholic Church. He always said that he stood on the shoulder of giants, and he did depend on Kepler, who developed the three laws of planetary motion. So he does form a bridge to what comes after, developing the idea that acceleration was independent of mass, which went against the idea of Aristotle, developing the idea of inertia, although he didn't develop a full theory of gravity. That depended on Newton, who came after, who developed a theory that explains how all objects in space relate to each other relative to their masses. Isaac Newton acknowledged the lineage of previous thinkers when he wrote to Robert Hooke, "If I have seen further, it is by standing on the shoulder of giants." Galileo's early career started in Florence. He enrolled in the University of Pisa to study medicine, but he soon turned to the study of mathematics and physics. There's a story that he developed a pendulum as a mechanism for timekeeping by being a bored teenager in the cathedral in Pisa, and watching the altar lamp lazily swinging, he noticed, according to measuring with his pulse, that it kept the same period regardless of whether it was swinging in a wide arc or a narrow arc. He was forced to leave the university due to lack of funds. His family was not wealthy, and he returned to lecture in Florence just to make money. He wrote a physics textbook in 1587 that was very influential, and it won him a lecturer position at the University of Pisa. But it was badly paid. We must recall that the position of professional scientist did not yet exist. He began his work on the theory of motion and developed the ideas of inertia and free-falling gravitation. Throughout his life, Galileo was a prolific author, and he wrote a lot of his work in Italian, not Latin, the scholarly language. So he was the first true popularizer in the history of science, determined that his ideas would reach a wider audience than the narrow circle of scholars that he might know. In this time, we can see and discern two threads in the philosophy of science, two traditions dating back to the ancient Greeks. From Aristotle, we have the idea that the philosophy as a thought process is the most important thing that humans can do. Mathematics is secondary for Aristotle. Laws of nature should be based on common sense and intuition, but they could have unlimited scope. He decided you could gain truth by arguing plausibility, and he developed the rules for deductive logic. And he also searched for causes behind events. From Archimedes, we have a slightly different tradition, where physics is most important, although mathematics is essential, and that laws of nature are based on simple mathematical principles. They might have limited scope, and they have to be verified by experience. So for Archimedes, the idea of experiment was fundamental, and Galileo strongly followed the Archimedean tradition. Archimedean science involved mathematics and experiment more than thinking. Laws of nature could be discovered by observation, not through the human thought process, and we shouldn't try to tell God what to do or what he should have done. In 1792, Galileo became the chair of mathematics at the University of Padua. This was a more prestigious university than Pisa. he got paid a lot more money, and he stayed in this position for almost 20 years. He discovered the uniform acceleration, although the story of him dropping objects from the Leaning Tower of Pisa is apocryphal. It was written apparently by a later student to buff up his reputation. But he was very clever at developing experiments to test ideas. He also tried to measure the speed of light. Was unsuccessful because the speed of light is 300,000 kilometers per second. He could not possibly have measured it. It's so fast. But it was a useful limit. You can see in this diagram the idea. He went to a hilltop and had a friend go to another hilltop. They each were equipped with lamps with shutters. And he agreed that on a signal he would open his lamp, and when his colleague, 2 miles away, saw the light, he would open his shutter. When Galileo saw the light come back, he would time it with his pulse, and so they would measure the time it took for light to travel perhaps 4 or 5 miles between 2 hillsides. Of course, in truth, that time is a tiny fraction of a second. There's no way you could possibly time it with your pulse. Even though this was just a limit, this was a good enough experiment to show that light traveled vastly faster than the speed of sound. These experiments were also proof that Aristotle's physics was wrong. The laws of free fall and inertia were clever experiments he used inclined planes for. This was basically just to slow down the rate of motion, as opposed to dropping something vertically, so he could measure it. He recognized that if the friction of different types of objects could be accounted for, they all fell at the same increasing rate. And the fact that heavy objects appear to fall faster than light objects, which was the idea of Aristotle, worked into a theory of physics, was wrong. That was not what actually was seen. As I said, he never did the experiment of dropping the ball off the Tower of Pisa. He realized that in the absence of friction or another force, a body would actually continue in its constant motion, and it was the resistance or friction of air or a surface that caused an object to change its speed. This to him implied that an object had heft or mass, inertia, its resistance to any change in its motion. So this is quite a modern idea, and it's essential to thinking about gravity the way Newton did. It might be possible to be in constant motion and not realize it, like someone on the surface of the Earth. He developed this law of free fall, slowing the acceleration of gravity and rolling balls down tracks. Very cleverly, he arranged for little bells to ring for timing, and he timed things with his pulse. He developed the law of inertia and also an important idea of relativity, the idea that the motion of the Earth, which Aristotle had denied, declaring the Earth to be stationary, was plausible because constant motion might not be detected. He imagined this with a thought experiment, which could easily be realized, of being in a boat under the deck on a very smooth surface of water. If the boat is drifting or moving at a constant speed, you could do experiments dropping objects or throwing them in the air or rolling them and not realize you were in motion relative to the boat being stationary. In other words, it was now plausible that if the Earth carried its atmosphere with it as it moved and rotated, that we might not know that it was actually moving through space. He spent considerable time in Venice and developed a long-term relationship with a woman with whom he had 2 daughters and 1 son out of wedlock. The daughters became nuns at a convent in Arcetri, outside of Florence, and Galileo corresponded throughout his life with both of them. There are 120 letters from one of the daughters, who is the nun, to Galileo, although his half of the correspondence is missing. Deva Sobel wrote a beautiful book called Galileo's Daughter, where she imagined both sides of the correspondence and Galileo's relationship with his daughter. This was later in his life when he was somewhat saddened and under house arrest, having fallen foul of the church. In Venice, he gained celebrity with his new telescopes. There are written documents that say that dignitaries doubted the evidence of their own eyes because they saw things that they weren't trained to believe with Aristotelian physics. But Galileo was astute enough to market it to the merchants of the town. Let's go back to this time when Galileo was in Venice.
2,000 years passed before a revolutionary breakthrough was made by a mathematics professor in the ancient maritime republic of Venice. In 1609, Galileo Galilei demonstrated an instrument that would soon be called the telescope. From the tallest bell towers, he showed that this device could spot approaching ships hours before their sails were visible to the naked eye. Later, when he aimed his telescope at the night sky, Galileo discovered that the moon was a world with mountains. Jupiter had its own moons, and the Milky Way was a band of countless stars.
Let's finish with the story that I said of how Galileo marketed his device to the merchants. Galileo didn't invent the telescope, although he was willing to let some people think that he did. What use was a telescope? He did use it to show the senior figures in Venice the wonderful things through the telescope: sunspots, the moons of Jupiter, the Milky Way. But what he gained money for was showing to the merchants that they could use a telescope to look out and see ships hours before they came to port. Why did this matter? Remember, Venice was a maritime nation that lived and died by trade. This was hundreds of years ago, back in a time when sailing was dangerous, when in any sailing set of ships that traveled together for security, ships were bound to be lost through storms, piracy, or getting lost at the open ocean. So of any set of ships that might come carrying valuable silk or spices from the Caribbean, there were bound to be ships that were lost. Galileo showed several rich people in Venice that with a telescope you could spot the fleet hours before it was due to come into port, a good part of a day. You could look at the flag of the ships and check the ship's manifest and find out which ships had been lost in the fleet. And if, for example, the nutmeg ship had been lost, this was a time when nutmeg, ounce for ounce, cost more than gold, you could walk around Venice buying up all the nutmeg in Venice and putting it in a warehouse, knowing that the price of your stored nutmeg would go through the roof when the fleet arrived and people found there was no nutmeg coming for the next year. That's just an example. It's a kind of an early form of the futures market. And so Galileo, as you can see, was a very savvy customer. Even though he was a scientist, he was recognizing other uses of the telescope. And that's the end of this topic.